So on problem number 3, they are asking us to answer a few things. We're supposed to find the equation for a parabola and find some heights. So here's what we know. It says that a section of suspension bridge has its weight uniformly distributed between two towers that are 400 feet apart. So let me draw the two towers that are over this roadway. So I have a roadway, and I have two towers that are 400 feet apart. I do know that the tower is also raised 90 feet above the roadway. So all the way to here is 90, and up to here is 90. So what's happening is that a cable strung between the top of the towers has the shape of a parabola, and its center is 10 feet above the roadway. So in other words, it goes downwards, curves back up, so that the bottom of the parabola is 10 feet above the roadway. So they want us to find an equation for this parabola. So to find the equation for this parabola, we probably want to draw it out to figure out what's going on. So we'll put the vertex right here on the y-axis. So it has a point of 0, 10. And then we'll put the top of the cable. So the top of the cable on one side and the other side to make our parabola. And we'll need to label these points. So these points are going to end up being 290. And the other one will be negative 290. And the reason why they are at 200 is because it's at the center. And because this is 400 feet, when you break it up into two parts, it's 200. So what happens is that we can end up finding an equation for our parabola by using one of the parabola formulas. So because we have the vertex and a point, we're going to use y equals a times x minus h squared plus k. So we're going to go ahead and first plug in the h and the k. So y equals a times x minus h, which is 0, squared, plus k, which is 10. So it really ends up being ax squared plus 10. So what's happening is that our equation still isn't done because we don't have a. But because they give us a point, this 290, that's technically an x and a y. So we'll plug the 90 into the y and the 200 into the x, and we'll solve for a. So I'll first subtract the 10 first, so I'll get 80 equals, and I'll square the 200, and squaring the 200 should give me 40,000. So I have 40,000 a. So if I want to solve for a, I'm going to divide, which makes it 1 over 500. So a ends up being 1 over 500. So my full equation will now say y equals 1 over 500 x squared plus 10. Alright, so we still have to go ahead and find b. So let's remember this equation. I'm going to have to erase half of this so it can fit. So let me erase it all. So let me write the equation again. So y equals, and it was 1 over 500 x squared plus 10. Plus 10, not plus 0, plus 10. So we'll use this now to answer part B. So part B says find the height of the cables at 80 feet from the center. So 80 feet from the center just means it's an x value of 80. So we're going to go ahead and plug in 80 into the x value and then solve for y. So we get y equals 1 over 500 times 80 squared plus 10. This is pretty much just calculator work from here. And from here, if you plug this in your calculator, you get about 22.8. So the height of the cable would be 22.8 feet. All right, we got one more for the section. All right, so problem number 4. Problem number 4 says a rain gutter is formed by taking a 30-inch wide rectangular metal sheet and building up the sides by x inches. So they want us to find the function that models the cross-sectional area in terms of x. And then for part B, to find the value of x that maximizes the cross-sectional area. And part C, what depth will allow at least 20 square inches of water to flow. So we kind of have to picture what's going on right here. So we basically have a 30-inch wide rectangular sheets. All right, so 30-inch wide rectangular sheets. So this is 30 inches right here. Okay. And then we're supposed to bend up the sides. So we kind of have to imagine that we're bending up parts here and part right here. so that it goes up. So the cross section ends up looking like this now. And the part that we're bending up, we don't know how big that we're bending up. So the part that we're bending up is x and x. So if you picture it, these will be your x's here. So because of that, this length right here is no longer 30. Because you're folding it up, it ends up being 30 minus 2x. All right, so from here, we're going to go ahead and answer the question now that we have the picture drawn. They want us to find the cross-sectional area. So the cross-sectional area, if you kind of picture it, it's just this area right here. So it doesn't really have a side right there, but we can picture a side right there. So it's just this area of this little box. So because it's just a little box, it ends up being length times width. So the length would be x, and the width would be 30 minus 2x. So to find the area, we just have to distribute. So it would be 30x minus 2x squared. So that's part A. For part B, they want us to maximize it. So again, because they want us to maximize, it's still x equals negative b over 2a. So in our case, it would be negative b, which is 30, over 2 times a, which is negative 2. We do a little bit of math, plug in our calculator, we end up getting this to be 7.5. So in other words, we need to cut out, or not cut, we need to fold up the sides so that they're both 7.5 inches. So we'll do part C now. There's no more space, so I'll go ahead and clear the page to get the space ready. Alright, so let me go ahead and write the formula one more time because I don't want to forget it and I need it. So area was 30x minus 2x squared. Alright, so for part C, they want us to find the depth that will allow it to have at least 20 square inches of water to flow. So in other words, they want this 30x minus 2x squared to be greater than or equal to 20. And so greater than or equal to 20. So in order for us to do this type of problem, we do need to find the x-intercepts, because remember in our previous lesson to draw or to solve these quadratic inequalities, we need the intercepts and then to picture the graph. So I'm going to go ahead and bring everything over to one side. I'm a little weird, but I don't like my x's to be, my x squared to be negative. So I'll add 30x and 2x squared to both sides. So 0 would be greater than or equal to 2x squared minus 30x. 30x, I wrote 3. 30x plus 20. Right. So I'm going to go ahead and factor. Right now, I can take out a GCF of 2. That leads to x squared minus 15x plus 10. Unfortunately, I don't know numbers that multiply to 10 and add to be 15, so we will have to use the quadratic formula. So we use the quadratic formula, x equals negative b, which is negative 15, plus or minus the square roots of b squared. Oops, let me write a little smaller. It's not quite fitting. Actually, let me just clear the page so that we can do this again, because I need more space. Alright, so let's try this again. So x equals negative b, which is a negative 15, plus or minus the square roots of b, which again is still negative 15 squared, minus 4 times the a value, which after we factored was 1, times the c value, which was 10. And it's all over 2 times a, which is 1. So we're going to have to simplify a little bit. That's 15 plus or minus the square roots. Negative 15 squared is 225. Negative 4 times 1 times 10 is negative 40. All over 2. So x will be 15 plus or minus the square root of 185 over 2. So there is no square root of 185, so you'll have to plug these in the calculator. So 1 with a 15 plus the square root of 185 over 2, which is 14.3. And the other one with 15 minus the square root of 185 over 2, which is 0.7. Oh, that 14.3 doesn't look like 14.3. Let me fix that. So those are our two values. Those are approximately where our x-intercepts are. But in order for us to figure out the inequality, we're going to have to draw these onto our graph. So if you kind of picture the parabola, where it's going to be, our x values that we had were 0.7, which is, we'll say right there. And the other one was 14.3, which is right there. And we know that our a value was equal to 1, so the graph opens up. So it will look like this. Again, it doesn't have to be exact. You just need to know which way it opens so that you can figure out what the inequality says. So because our original inequality says 0 is greater than or equal to 2x squared minus 30x plus 20, we need the stuff that is negative. So this has to be less than 0. So if you can't interpret that, that really just means less than 0, which means we're looking for the negative sections. So the negative sections are this part right here. So we need at least 20 square inches of water. We need it to be between that 0.7 inch and 14.3 inches that we found on earlier in the problem. So that's the last problem on chapter 2, section 6.